Am I audible?
Can you hear me? Human, huh? How you get the time from Vijay batch to attend? Are you Vijay Duman from the Vijay batch? Good evening, everyone. Just let me know whether I am audible or not. That is the only thing I needed to start the session. Am I audible? Okay, great. Thank you very much. Okay. A very good evening, everyone. I welcome all of you to this session of C programming lecture series, which is going on at 6:30 p.m. daily, and it will continue for the next week as well. We will cover data structure, some part of the data structure. These are the important topic. These are the important topic that we are discussing over here. We have discussed recursion, we have discussed function, loops. Okay, so all these things we have covered. Even if you go glimpse and you find some more let's say practice question, then definitely you can do good in this topic. So yesterday we have covered a very important topic, that is recursion pointer. Okay, so that is this is the summary for today, yesterday's lecture. We have a pointer, we have a pointer, and we have seen the ampersand and dereference operator. How does it work? We have seen single pointer, double pointer, multiple pointer. Okay, coffee. Okay, okay. Today we are going to talk about a bit of pointer arithmetic. First, I will start with this pointer arithmetic, the mathematics behind this pointer, and then I'll explain you 1D array. Okay. And if possible, I will also touch call by reference. Let's say whether I can touch it or not, but this is the first primary agenda is pointer arithmetic and call by reference. Let's see I can touch it or not. Okay, let us start our discussion with the pointer arithmetic. Now this is very important for understanding the array arithmetic, and the question they ask in the examination is from the implementation point of view, that how a pointer and array are related with each other. Okay, they ask question related with this, that how this they are combined or joined with each other, how they work with each other. Okay, to understand how the pointer and the array works together and how array is basically implemented by using pointer only, we need to look at this aspect of the pointer that is called pointer arithmetic. Okay, and it's very simple. It's very simple. Okay, now suppose that there is an integer pointer, and I'm assuming that I can assume it that ptr is equal to 1000. I am assuming this value. Okay, I am assuming this. I am assuming this value. It's an integer pointer. Now, if I have also need to assume one more thing, that what is the size of integer. So now this is a size of I am writing of integer. Generally nowadays 4 byte, character 1 byte, float 4 byte, and double 8 byte. This is general aspect, 4 byte, 1 byte this. Now if I say, if I do the arithmetic operation, computer pointer arithmetic, so now understand in pointer arithmetic what is allowed: addition and subtraction with a constant. What you can do, addition and subtraction with constant is allowed, with constant is allowed. So now if you're having a integer pointer, if you're having a pointer, PTR you can do plus C, PTR you can do minus C. This is allowed. Okay, addition and subtraction with a constant. C is what? C is a constant. What is also allowed, because of this addition and subtraction, it implies that we can also apply plus plus and minus minus operator in pointer. You can do the plus plus of address and you can also do minus minus address. In a way, it is nothing but the addition and subtraction with a constant. C is 1. Okay, so this implies that this is allowed. Multiplication division is not allowed. Okay, if you have an address and I'll say I'll multiply the address with 4000 and I'll 4 and I'll go 4000, it won't happen. So multiplication division is not allowed. So plus you can do with pointer address, minus you can do with pointer and address, plus plus you can do with pointer, minus minus you can do with pointer. Now if they are compatible with each other, okay, if they are compatible with each other, then you can also apply, you can subtract two pointer. Okay, for compatible, for same data type, same pointer data type, okay, same pointer data type, what is also allowed, if PTR 1 minus PTR 2, this situation is subtraction can also be done. So now first you understand that when I say arithmetic, so all the things are allowed. No, all the things are not allowed. In cases we can do addition with C, minus with C, we can do plus plus and minus minus operator we can apply. And if the two pointers are compatible in a sense, both are integer, both are character, both are float, then I can happily do the subtraction of them as well. Okay, happily I can do the subtraction of them as well. So this is allowed. Now what is very important here in this case is that our instinct is what? The moment I will say instinct that comes from inside, 100 plus 1, immediately you will say 101, because we have been taught in this manner from the beginning, let's say from the childhood. 100 plus 1, 101, 100 plus 3, 103. That thing changes here in this case. So what exactly, how does it change is this: when I say PTR and I say PTR plus C or minus C, PTR plus C, or I say PTR minus C, okay, so now it doesn't work like normal arithmetic. How does it work in this way? Is pointer PTR plus C into size of data type, size of data type. It works in this manner. It works in this manner: PTR plus minus C, so that will be C multiplied by size of data type, size of data type. And what is the size of data type? So that I was focusing over here in this. No Hindi beta, this is not a Hindi channel. When we'll do the session for Hindi channel, then we will do in Hindi. Okay. Now here, so size of the data type, 4 byte, 1 byte, 2 byte and 8 byte. These are the size of the data type. And how the array works, because array, I'll just give you the introduction after this. Array is basically nothing but sequential arrangement of element, sequential. Okay, sequentially they are arranged. Now if it is an integer pointer and I say PTR plus C, then this pointer will be 1000 plus, okay, let's have a C value, PTR plus 4, then this will be equal to 1000 plus 4 into 4 and it will become 1016. Why? Because it's an integer pointer. If it is a pointer ptr, let's say 1, and let's assume again that ptr1 is also 1000, and if I say ptr1 is plus 4, then this will be also 1000 plus 1 into 4, and sorry, 4 into 1, 4 into 1, and that will become 1004. Okay, so it directly doesn't add the thing directly over here. When I say plus 4, now we have to apply 4 into size of the data type, because it's an integer pointer multiplied by 4. ptr1 is 1000, ptr1 plus 4, 1000 plus 4 into 1, and that will become 1004. If I take a double ptr, okay, and if I assume, these values are assumed, double ptr, if it is a double pointer, double ptr2, and let's assume that ptr2 is equal to 1000, and if I say ptr2 plus 4, then it will be equal to 1000 plus 4 into 8, and it will become 1032. So now understand that here in this pointer arithmetic, we have a certain rule of addition and subtraction, which is not similar to the standard arithmetic operation. And whenever we do the addition and subtraction, the addition will be not only of the constant but size of data type. Why it is happen? Why does it happen? Okay, so the explanation for this is that if this is the address, why it is so 1000, and suppose I am storing an integer over here, so this will occupy 4 byte of the space. Okay, this will occupy 4 byte of the space, and that means here it will be 1000 1 byte, 1001 another byte, 1002 another byte, and 1003 another byte. 1 byte, 1 address, 1 byte, 1 address is called basically byte addressability, is called byte addressability. 1 byte, 1 address is called byte address. Very good evening. So now when I say if the starting address of an integer I'll give, and I say okay, you do 1000 plus 1, now it is an address, it points to the idea is it will point to the next integer, it will points to 1000 plus 1 points to next integer. Okay, so now the next integer will start from 1004. So now, and that is the reason that when you add something 1, it jumps, 1000 will jump to 1004. Again, if you add plus 1, it will go here, in this case is 1008. This is the same way your array is being stored in the memory. Same way this array arranged in the memory in a sequential manner, one after another. And one after another, they are starting is 1000, then we go to 1000, next element will be 1004. So this is offset. What is it is called? Offset by 4. This 1004 to 1008, again it is offset by 4. So now all arrangements of the memory will be in the 444 offset here in this case. This is how pointer arithmetic works, and this is my first concept of the day that I want to learn. I want you to learn, and I want you to understand in a complete possible manner that pointer arithmetic and this operation is allowed, and this is how it is done. Okay. Now let's put this concept aside, and let's come down to today's topic, which is array. Sir, are we done with this? What is the utility? Where is the application? I will come to that. Okay, I'll come to that. Now Let's come to the, after pointer arithmetic, let's come to the array part, and I'll come back to that part again. I'll come back. Now, now first of all, array is what? Array is a sequential data structure. What we call it as a sequential. Okay, array is a, let's call it as a linear data structure. Linear data structure. Sir, my handwriting mistake, so after I am not getting you, beta. Chetan, huh? Chetan M. I am not able to get you what you are trying to say. So it's a data structure. Huh? What is the data structure basically? There is only one and only one goat. It's Lionel Messi. Okay, Lionel Messi is the only one and only goat. Nothing else. Chaliye. So it's a data structure. So arrangement of the data, linear data structure. Okay. Second, the point, the element. Okay, array is, basic definition, array is collection of similar data type. Similar data type. Okay. So now that concept, similar data type. Okay, similar data type. Array is a collection of similar data type. Now the same concept in the is one of the another user defined data type. This is a again derived data type. Array is a derived data type. It is not having its own existence, but array is a derived data type. Array is derived data type. Derived data type. Okay. So derived data type means character array, integer array, float array. Okay. So this is a derived data type. Array is a derived data type. One more data type is there where we will again learn later, but not now, is a data type which is dissimilar, collection of, this is also important, so I am mentioning it, collection of dissimilar data type. Dissimilar data type, and that is basically structure. Okay. So if you want to structure, the structure is structure. So in a structure you can take different data type here. You can take one integer, one character, you can take a pointer, you can take array, anything you can, and club them together. Okay. So it is basically a similar, homogeneous, and that is another term, and that is non-homogeneous in this cases. So it's a derived data type, and this one is user defined data type. What is structure is that user can define user defined data type. Now the best part here about the array is that supports it's an issue of data structure, but I am mentioning it here. Array supports array with using array we can randomly access element in constant time. See, understand, and this is the best part. This is about the array. That is the advantage of the array. you want to, like, what is the meaning here in this case is that you want to access, suppose the 100 elements are there, you want to access the first one and you want to access the 100th element, random access memory, same random access in this case. You want to access the first element or the last element, it takes the same time. That is the best thing about the array. The disadvantage of the array is that it needs a consecutive memory. Now you suppose you need a data for 1 lakh candidate or 1 lakh elements you want. You want it has to be arranged in a single straight sequential memory. That is the biggest disadvantage. But what it offer here in this case is that you can randomly access the first element as well as the last element. The whole idea of the C programming is how this constant time occurs. To explore this idea that how this constant time occurs. Okay. Now, another basic thing about the array is that let's start with the declaration. We declare the array, let's say A10, 10 is more, A5, and I declare this by using this 1, 2, 3, 4, 5. Okay. Now, this is the 1, 2, 3, 4 and 5, and suppose these elements are stored here in this cases. Let me take something like 11, 14, 16, 29 and 6, semicolon. Okay. Now this is element 11, 14, 16, 29 and 6. Okay. Now in this cases, that how to access the, now you have arranged. So integer accessing is very simple. You take the name and it will be accessed. To access the array element, we have to use the index. Okay, we have to access the element, we have to use the index. To access array element, we have to use index. And let me say, data structure theoretically it can start from anywhere, but this is index number 0. So I want to access, it will become A0, this is A1, this is A2, this is A3 and this is A4. C language, the index value start from 0. C array index starts from 0. Okay, this is the thing that you have to, good evening, remove. So C index starts from 0. Now obvious question, why 0 sir, why not 1? In the entire our life we started the value from 1, we ignored the 0, though India discovered the 0. Okay, though India discovered the 0, but why we are starting from 0? In the whole life, even the first year student, I find it very confusing. Okay, the exact word is, I find it first time when I learned that array index start from 0, I find this concept very confusing, that why 0? When everything was starting from 1, 2, 3 and this is how we count it, why to suddenly start with 0? Okay, 0, 1, 2, 3. So we'll see the reason why it starts from 0. So this is the way it appears. Now, the next part is, it is true for all programming language. They are start with 0 only. Now, array and pointer relation. Array and pointer relation. The first thing when we start array and pointer, okay, first thing when we start array and pointer, the very first thing is that name of the array. This is something that we have to learn, remember whatever way we can. Name of array is starting address of first element. Okay. Now, oh my God, too big. Chalo. Okay. So this is the thing that we must first address and learn, that name of the array is starting address of first element. Okay, first element. This is how it starts. Okay, the name of the array, when I declare the array, okay, this is the array when I declare, when I say A5, what is A? So A is basically a pointer, and this is how, if you are thinking when we are passing parameter, so I'll pass the entire, if there is a A5, then I'll pass entire 5 element as a parameter. That doesn't happen. That is one of the reason that, okay, we pass only the starting address. Okay, we only pass the starting address. We never pass the entire array into that. Okay, we never pass. So here in this, let's deal with address. So let's start with address also. 1000, change of color. 1004, 1008, 1012, 1016. Fine. This. Let's have this address. So now here name of the array, starting address of the first element. So we never pass entire array. We never do this. We pass only the starting address. He do the manipulation and then come back. Now, so A, when I say A is address, and in this diagram, A, value of A, if you say, value of A is address 1000. Now, let me give you one more understanding of the array. When I say AI, okay, AI, to access the element, this can be expanded. If you know, fine. If you don't know, then understand. Dereference A plus I, okay, is equal to dereference I plus A, is equal to dereference is equal to I of A. This is, I am talking about C language. Please listen to it carefully. These four terms are equal. Okay, these four terms are equal. Let me demonstrate. If I do not demonstrate, you won't believe. So demonstration is important to understand and see. Screen should be visible to you. Yes, it is visible to me, so it will be visible to you. Now quickly, what we will do here in this case is we declare an array int A, let's say 5, will not take any chance, 11, 12, let's say 13, let's say 14, let's say 15, semicolon, and I know that array index start from 0. So now here in this case, let's target this A3. So let's say this printf %d. Third element I am targeting, I will write A2. Okay, I will write A2. Fine. So it will print the value 13. Okay. So it should print the value 13. So it is printing the value 13. Now see, I am not interested in showing this because you know all this thing. What I am interested in showing you this. Dereference within bracket A plus 2. Okay. A plus 2. Dereference within bracket 2 plus A. This I am interested, and I am interested in 2 of A, 2 of A, and let me go to the new line so that it can be visible in the next line. So we have A2, dereference A plus 2, 2 plus N, 2A. Fine. Let's run this. See, all are same. Okay, all are same. All these four notations are same as I have shown in this here. A2, dereference A plus 2, dereference 2 plus A, and last one is 2 of A. Okay, 2 of A. All four are here in this case. You can see printing the same value, that is equal to, in this case, is 30. Okay. So the first thing that we learned here in this case is this. Now tell me, I can access the element in this manner. Okay, index outside, and variable name, array name inside. Can I declare the array in the same manner? 5 and A. Can I declare in this manner? Answer. I am not able to see your comment, but now you answer it. Can I declare into the same manner? Can I declare in index outside and A inside? Can I do in this manner? Possible? Access I can do, but can I declare in this manner 5 and A? Okay. Now let's run and see what error it gives. Let's run and run and see that what exactly the error it gives. So let's see what error it gives. It says that expected identifier or bracket before the numeric constant. Okay. Second error, it is saying that A is undeclared. Okay, A is undeclared when you say A2. So here it is not taking 5 as a name. Okay, now if I say this and underscore, I'll tell you the reason why I'm writing underscore, and if I just comment this everything out, underscore 5A, let's run this. What does it say? Okay, it is saying A is undeclared. Okay, A is undeclared. Of course, yes, A is not been declared here in this case. Suppose I say A is equal to 10. Okay, I declared A as well, and this is how I am running. Is it fine now? Variable size may not be initialized except the empty initialization. Okay, so something it is doing. Okay, let's come back our point. So this is allowed, but declaration in this manner is not allowed. Declaration, if you say 5A and you declare it as an array, it will give you error. Okay, you can access in this manner. Access is allowed. Access element is allowed. Or rules of naming, identifier rule convention, identifier cannot be start with number. Exactly. So that is the exact reason. Okay, now coming back to this, if I take the same example over here, and if I say A2, okay, so look at here, A2, now you know the dereference A plus 2 is equal to dereference, look at here, it will become 1000 plus 2. Let me write the value. Okay, this. So when I say A2, it is dereference A plus 2 as we have seen, and it will become dereference 1000 plus 2. Now tell me, everyone, if you are listening to me, then tell me 1000 plus 2 is equal to what? What is 1000 plus 2? What is 1000 plus 2? What is 1000 plus 2? If you are listening to me, tell me what is 1000 plus 2? I didn't skip anything. This is what you have to learn. Okay, this is what I was saying to you. Okay, that is why we learn pointer arithmetic. 1000 plus 2 is not 1002. Okay, this is the point that I was making earlier, that 1000 plus 2 is not 1002, and 1000 is not your number, it's an address. Okay, pointer plus c is equal to, the rule will be applicable, c into size of data type. So this is what I was talking about, that whenever we deal with a pointer, 1000 plus 2 is not 1002. Okay, you understand? 1000 plus 2 will be calculated dereference 1000 plus 2 into 4, and that will become dereference 1008. Okay, dereference 1008. So it will come to this position. Okay, and since it knows that it's an integer, so from 1008 to, it will go to any other byte, 4 byte it will take, and the whole value that here in this case is dereference 1008 is equal to 16. Okay, this is how elements are accessed in constant time, because it is having a formula for it. Every array is having a formula, and that is the reason that it works very well, and that leads to random access. Okay, that leads to random access. This is the reason it is randomly accessed, and this is the reason that any element are arranged with Go. The main important part that everyone, and I said that you will forget, and the same thing happened, that you are not able to understand this particular part, that if it is an address, you do plus c. Okay, address plus you do plus c. Okay, then it will increment according to the size of plus 4 integer 116, character plus 4, 4 into 1 1004, double plus 4, 4 into 8 1030. So this is one of the important aspect for pointer arithmetic. See, now this is the important part. Let's put them in the bracket and let's write here important. This is what they ask in the examination. This is the thing from this particular topic array, they explored in examination, already explored, and they will explore. Okay, good. Now what? Okay, let's start with this. Okay, Python is your favorite language. I totally agree with you. Python will give you lot of function benefits. It's quick, fast. It is interpreted, not compiled. And also you notice that in Python you have a concept of negative index, right? Negative index. And as far as I remember Python, this is -1, this is -2, this is -3, this is -4, this is -5. As far as I remember that it is this. Okay, -1, -2, -3, -4, -5. We do not have direct concept of negative index in C language. We don't have direct concept, but using pointer we can still have a negative index. Let's explore this problem. This is your array. This address is suppose 1000, our usual 1008, 1012 and 1016 usual. Okay, now A is an array, and now we have taken a different pointer. B is an integer pointer. What is B? B is an integer pointer. So now tell me if I say B is equal to A plus 4, similar concept. A means whenever you say name of the array, it will be the starting address of the first element, 10, which is 1000, and it will become 1000 plus 4, and that it will become, what will be the answer? Now you are aware of it, so let me not ask you. It will become 1016. Okay. So in B, the value that it getting stored here in this case is 1016. So B value, B is a pointer, and it will hold the value here in this as 1016. Okay, 1016. Now look at this statement, B minus 1. Okay. What does it say? B minus 1. So now it is not writing A minus 1. Okay. Remember that it is not writing A minus 1. I am using B minus 1. What is B minus 1? Dereference B minus 1. What is this? What is the B value? So it is 1016 minus 1. And if you do minus 1, it will be 1016 minus 1 into 4. Okay. And that is equal to dereference 1016 minus 4, and that will be 1012. 1012, the value in this case is 40. So answer for this question is 40. You are right, Rituj. Ritu Jethani. Okay. So answer for this question is 40 here. So answer for this particular question is 40. 1016 and answer is 40. Now answer this one if you are able to understand. Answer which is the correct option over here. Minus 4. Does it? Was it minus 4? There was one minus 4. It was minus 4. Pointer arithmetic. Pointer arithmetic. I think I am. You're taking breaks in between in 1 hour of class. Are you taking breaks? Because I started the same thing with the pointer arithmetic only. Minus 4 means minus, it was minus 1, but again because it's an address, you have to multiply with the size. Okay, and size is 4, as simple as that. That's why we're getting minus 4. Minus 116, 115. That is your, if 1016 is a number. If it is a number, then 1016 minus 1, 1015. Okay. But if it is a pointer, I'll do again. I'll do something like that here. So understand why it was like this in this question. So let's have this as 1000. Let's have this as 1004. Let's have this as 1008, and let's have this as 1012. Okay. Now, when I say pointer B is equal to A plus 3, A is what? The first address. What is that? 1000. Up 1000 plus 3. Now this time you should exactly ask, is it 1003? No, It is not 1003. It will become 1000 plus 3 into 4. Why? It's an address. It's not a normal number. It's an address, and it will become 1012. Okay. So my pointer B contains the value 1012. Okay, 1012 it contains. Now I say B minus 2. Okay, B minus 2. So now B minus 2, how will write B minus? I know the B value. D reference B minus 2. I know the value of B. D reference B, which is 1012 and minus 2. Now, every other student you will ask here, every other student which is non-civil, mechanical, so they will ask what is 1012 minus 2? They will say 1010. But as a computer science student, you have to ask what 1012 is. Is it a data type? Is it an address? It's an address. So then it will not work in the normal way. 1012 minus 2 into 4, and that will become 1004, 1004. And D reference 1004, look at your diagram, 1004 is 23. The correct answer for this question is 23. Okay. So we are just giving a larger index, and then we are, minus means we are coming back. So plus 3 minus 2, 1, 23. Yeah, as simple as that. You don't need all this thing. It just, you got 3 away and then 3 step forward, 2 step backward. Okay. So where you reach? 1 step. So one answer is this. And all these calculations are, you have to understand. It is required. It is needed. These calculations are needed. Now, one more thing that I want you to understand is this particular question. This. Please answer this one. It's a knowledge based question. Some of you may not be aware of, but after this question, you will be learning a new, not concept, new, your knowledge will increase after this. Your knowledge will increase. Go ahead. I'm completely away from this. I'm completely away from the screen as far as I can. Great. Now, before this, whatever question we have done, okay, before this, whatever question we have done, you see, I have taken another pointer variable. 2 questions we have completed, 2 questions we have done. I have taken another pointer variable, and in that pointer variable, I have taken the address of the array, and then I have done the incrementation or decrementation. Incrementation only I have done, but you see that I have taken a separate pointer variable, okay, separate pointer variable, and then I say a plus 4. In previous question as well, here also, I have not taken a plus 3, I have not done, okay, a is equal to a plus 3, I have not done. See, understand, and it's a knowledge based, I will not even say that you should know or it's a great thing, or it's just a knowledge based question. The understand is this, that the base address, the name of the array is the first element. What is the concept? The name of the array, is address of first element. The name of the array is address of first element. You understand this? This association of B and, suppose if I take this address as 1000. Now, one way of understanding, B value is 1000. This association is a constant association, means this value that is associated with B is a constant value. Meaning is, base address of an array cannot be changed. Okay, base address of an array, meaning is base address of an array cannot be changed. Cannot be changed. You cannot update this value. You cannot say B plus plus. Okay, because if you say B plus plus means you are updating it. See, there is a difference in saying B plus 1 and there is a difference in saying B plus plus. Understand the difference, B plus plus. When you say B plus 1, B is not updating, it will not update B. It will not update B. B still, what is B? So B is 1000 only here. But when you say B plus plus, it is a modifier. Okay, it is a modifier. And if it is a modifier, it is like B is equal to B plus 1. Okay, this is not allowed with array. With array address, it is not allowed. So this is a error. Address increment, no, it is an error. This is an error, and the name of the error is L value required. When you run this program, you will find this error, L value required. L value means address. It is associated with a variable, it is not associated with any constant. Okay, so you cannot update base address of a array. Base address of an array cannot be changed. It is constant. It is constant. It is constant. So this you understand. Okay, this you understand. The base of addresses cannot be changed. Very well, very well, very well. Great. I was about to say one more thing to you, but practically I forgot. I was about to say one more thing to you, but practically I really forgot what I wish to say to you. Okay, fine. Let's talk about this question. Okay, let's talk about this question. Last question. This you can say as par with the GATE examination. This you can say this is as par as to the GATE examination. Now tell me what it will output. You can take few minutes. I'll just I'll be off, not in the front of the screen. Answer. Okay, answer for this question. Any idea? You can give up, but I'll say that okay, attempt it. A pointer is there, base address assigned, plus plus star p is there. Okay, so attempt. Error. Why? Error is not an option. Not an option. Error is not an option. Chalo, I got one answer, that is enough for me. Okay, so we are getting some answer over here, and let's start with this. Let's start with this and let's make it over. Then you enjoy your weekend. I'll give you one or two problems to complete. Let's say P is equal to B. P is equal to B. Okay, B is the base address. I have taken the value 1000. Okay. Now, what is the meaning of PYQ? Book you purchase. PYQs are available up to certain soft copies available, and answer is also available in the website. So you don't want to spend money, don't spend. Download all the lectures. Even if you do a little bit of search, I think you will find some soft copies also. There are many websites are there from where you can do the PYQs. But I will suggest that take one hard copy as well with you. Now, plus plus dereference P. Now see here, plus plus dereference P. Now here, first thing that will happen is the dereference. P is 1000. So now first thing that will happen is dereference. So I will go to the 1000 place. This is my dereference. Yesterday I told you 1000 pointing to, I will go here and I'll do the plus plus to this, and that means this will become 3. Okay, this will become 3. So dereference plus plus, one of the important for GATE examination, they ask this. Okay, they ask this. So you do the dereference and do plus plus, increment it, so this 2 will become 3. Immediately you are coming and printing the value. So the first answer is 3. The moment first answer 3 comes, you can say D is the answer, game over. Okay, D is the answer, game over. Okay, the moment you get this answer 3, game over. Why I will again go for the next part? What is the need of going into the next part? But I'll say, now you say P plus equal to 2. Now that is exactly equal to P is equal to P plus 2. And that means 1000 plus 2. Now you don't say 1002. Now you are grown up. You will say 1008. And what is in 1008? Dereference P. Dereference P. 1008. That is dereference P. That is equal to 4. So 3, 4 is the correct answer. Thank you very much. I will see you tomorrow. On Monday. And I am giving you one homework. Please complete this problem. And this problem is this. Okay, this is the homework question for you. It's a PYQ. It's a PYQ, and I believe that year is 2016. I may be wrong as per as my memory concern. This is I'm not doubtful, but it is a PYQ. Take the screenshot, or you can later visit the video and you can again take it. Yes, it's now dinner time. So friends, this session comes to an end. Beautiful interaction with you guys, and now we'll prepare dinner and then we'll eat. There is no option of sitting in the table and getting the dinner. So we'll prepare and then we'll eat. Thank you very much. I'll see you on Monday. Monday I will start data structure. Okay, Monday I will start data structure. This entire session of 2 weeks will give you guidance that how you should learn, what you should focus on. Okay, what you should focus on. 6:30 data structure. So your foundation will be laid, then you can create your, not building, I'll say, you can create your castle over there. Okay, thank you so much guys.